So we're getting up there. We're almost done. Less than 6.7. What we're going to be looking at is, first of all, unit vectors. We just talked about these in 2-space. And we talked about how unit vectors, where I was the equivalent of 1, 0, and j was the equivalent of 0, 1. Well, that's when we're working with 2 dimensions. Okay? We're now working with a 3rd dimension. And I'm going to give you a unit vector for that. Of course, we have to write our vector symbol above. Our next one will be k. Well, k only deals with 3 dimensions. Okay? So what I'm going to end up doing is I'm going to change I and j to a 3-dimensional type question here. Instead of ending there, we just have to add zeros for the value of z on these. Okay? So in other words, technically, unit vector I is 1, 0, 0. Unit vector j is 0, 1, 0. And the unit vector k is 0, 0, 1. Again, they all have a magnitude of 1, and any vector in 3 space here can be explained by a combination of scalars of these. Okay? And that's a lot of words all packed in together, but let's try to make sense of it. We'll quickly show you what each of these vectors would look like. Our x value of the vector, that would be our I. Okay. So that's positive 1 direction. There's our unit vector of I. Our j would be right there. This is the unit vector j. Unit vector I. And finally, unit vector k, not z. It's on the z-axis. Would be on the z-axis there. And that would be our k unit vector. Okay? So we can represent all the vectors with scalars of these. We make them longer, shorter, and combine them together to make a vector in 3-dimensional space. What we're going to do, changing these to component form and standard basis form is the exact same thing. For instance, I'm going to give you one very quickly. We'll briefly talk about it, but I don't want to go in too depth because I want to move on. We did talk about this in 2-space. Remember we talked about, let's say I have a vector -3, -1, -4. Okay? So here is some position vector. Our position vector is going to start at the origin and go to this point. So we can call it OP if we like. Our position vector. And we would make a combination of this. This is already in component form. -3, -1, -4. These are the components of the vector. How can I write them in standard unit vector form? J minus 4k. Exactly. That exact same idea. The only difference is we have a vector of k, and don't forget to put the symbols. Okay? Because what we're saying is our vector here is a combination of the scalars of these vectors. And I'll quickly show that again. -3i, well, that goes back in the other direction. That would give us back 3. Got our red color here. So essentially that would be going back 1, 2, we'll say that's roughly 3. Okay? -1 for y takes us back 1 that way. This is blue. And our k is -4, so that takes us down 4 units from where we are. So we go down 1, 2, 3, 4. Okay? And we'll make the box so that everything looks similar. We can see exactly what it is we did. I apologize, I know it takes a while to make these. So here is our three-dimensional rectangular prism to help with our idea of what this position might look like. Okay? And our positional vector goes from the origin, okay, to our new point, and our new point being over here. Okay? So there's our new point. And what our standard form tells us is that this new point is a combination of negative 3i, the unit vector, so a scalar of that, minus 1j, so a scalar of j, the opposite direction is positive, and a scalar of unit vector k. So we can combine all of those to get our new vector here. That's essentially the idea behind it. We've done that part. We're going to jump ahead here. Selecting a strategy to determine the combination of something. So a lot of times what ends up happening now is we'll jump to a new page. I'll get a new vector going on here. Actually,